Okay, today I'm going to walk you through, excuse me, 5 or 6 problems that have equations that have a variable on each side. Okay. So we'll start off with this one. We're going to use all the same rules that we've been using to solve equations, multi-step equations. But we're going to do this. See, this one has an 8s and it has a 7s on the opposite side of the equal sign. So we need to get those together, okay? And that's usually one of our first goals, is to get those variables on the same side, because if we get them on the same side, then we can solve for it, okay? So I'll do a couple of them with this line down it to make sure that we're doing the same thing on each side of that equal sign, okay? So on the right-hand side, I'm going to get rid of the 7s by subtracting 7s, and I'll explain that a little bit more detail here. I could have gotten rid of the 8s by subtracting 8s on both sides, but if I subtract 8s from 7s, I'm going to get a negative number. So I'm going to have to deal with a negative number later. So instead, I just find the smaller of the two coefficients on my s variable. So 8 and 7 are the two coefficients of the s variable. I find the smaller one, and I'm going to subtract that one away. Or it could be add that one to the other side, if it happens to be a negative number. Okay, I just prefer to work with it. It seems to save me a step. Okay, prefer to work with positive numbers. Okay, so now I'll just do the subtraction. 8s minus 7s. Here is 1s, or s. I still have the plus 9 equals 7s minus 7s is 0, plus 6 is 6. And now we just have a single step equation. This one was set up really nice, so that after we got the s's together, it turned into a single step equation. And the one step I need to do is get rid of the 9 by subtracting 9 from each side. So s equals negative 3. Okay? Okay, to check your problem, you could go ahead and take that negative 3, and you can plug it in wherever there was an s in this original equation. Okay? I'll just tell you to do that, and we'll save that one for you guys to try out. Okay? Okay, the next problem, fractions. Okay? Again, we don't always like to deal with fractions, so I'm going to show you one with fractions and how you can get rid of them. Okay? The denominators on all of these fractions is 4 or 3. Okay? The least common multiple of 4 and 3 is 12. So what I'm going to do is I'm going to take that least common multiple, and I'm going to multiply the entire left-hand side of the equation by 12. And I'm going to multiply that entire right-hand side of the equation by 12. Okay? What this is going to do is it's going to help me get rid of the fractions. Now you can see how that works when we do this. Now, make sure, because the rules of math say that if we do something to one side of the equation, we have to do it to the other side. We are multiplying the entire left-hand side by 12, not just the 1/4. We have to multiply both terms by 12. Okay? So I put it in parentheses. So that parentheses signifies that I need to distribute. Okay, and I'm going to have to do the same thing over here. Okay? So in one step, I'm going to distribute both sides. Okay, and we should be able to do this pretty much in our heads. Okay, 1/4 of 12, or 12 times 1/4, 1/4 of 12 is 3, minus 2/3 of 12. Well, if we divide 12 by 3, we get 4, and 2 4s is 8. So 8y equals, turned out pretty nice already, 3/4 of 12. Okay, well, if 1/4 of 12 was 3, 3 3s is 9. So that 3/4 of 12 must be 9, minus 1/3 of 12. Okay, we've already gone through that. That's 4. Y. Okay, now this problem looks like the last problem we did. Okay, we're very similar. Just a variable on each side. We need to get rid of one of these. Okay, now we can either add 8y to both sides, because we have a minus 8y here on the left-hand side, or we can add 4y to both sides because we have a minus 4y on the right-hand side. Like I said in the last one, I prefer to add 8y to both sides because that's the smaller of the two. okay, and that should help me out, okay, or at least it's a possibility that it'll get me a positive number, and this time it does, okay. 3 minus 8y plus 8y is just 3. Okay, then I have 9, and then negative 4y plus 8y, that's the same as saying 8y minus 4y, okay. That's just going to be a 4y. Okay. Scroll down a little bit. Now we need to get everything away from the variable. Okay, multi-step equation. Get rid of the 9. Subtract 9 from each side. 3 minus 9 is negative 6. Okay. 9 minus 9 is 0, plus 4y. Okay, now we need the y by itself, so we're going to divide by 4. 4's cancel on this side, leaving me with just a y, equals negative 6 divided by 4 is going to be a negative, let's see, those are both reduced by 2, so 3 halves. Okay, so you can change that around if you are not comfortable with that. A negative 3 halves. Another way to write that is to write negative 1 and 1 half. Okay, and again, you can take that answer, plug it into the original equation for both y's, and see if it turns out. Okay. Okay, another one. Okay, again, we have parentheses on one side. This time I'm going to leave that middle bar off and just show you how that looks without it. If you still need to use it, use it. Okay. It can't ever hurt you, so it's a good thing to do to draw that line down, the equal sign, if you need it. Okay. But in this case, distribute on the left-hand side here. So 4 times f is 4f. 4 times negative 2 is negative 8, equals 4f. And now I want to get the variables on the same side. Okay, and I've always said pick the lowest one. Well, they're both the lowest one, or they're both not the lowest one, whichever way you want to say that. So let's just get rid of 4f on both sides. So minus 4f, minus 4f. Both sides of the equation. So 4f minus 4f is 0, so this is negative 8, equals 4f minus 4f is 0. There's nothing left on the right-hand side. Okay? We came up with a false statement. Okay? Now, this is a special case. Okay? So when the variables drop out, or are removed, okay, drop out during our process, the variables drop out, and we're left with a false statement, and the statement is false. There are no solutions. So our answer to this problem would be no solutions. Okay? So the variables went away. The statement I ended up with was false. So my answer is going to be no solutions. Now, what does that mean, no solutions? Well, what that means is that there's no value for f that you can plug into that equation and make the equation work. Okay? Try as you might, but you cannot plug something into f here and plug that same value into there and make that equation give you a true statement. Okay? And that's what equations are supposed to be. Things that you can solve for the variable and get a true statement. Okay? Okay, let's try this one. We got another fraction, 2 distributions it looks like. Okay, so let's work with the 2 distributions. Really, if we wanted to, well, we'll save that for after we distribute. Because it looks like the 1/2 or that 1/2 fraction isn't going to hurt us. Because if you take a look at that right-hand side, you know that half of -12 is going to be an integer number, not a rational. It's not going to be a fraction, is what I'm saying. And then half of 30 is also going to be an integer value, not a rational value. Okay, so we're not going to have to deal with fractions after we distribute, so that's really nice. Okay, so we'll just distribute this. Now remember, when you distribute, remember to distribute the sign that is left of the number you're going to distribute. Take that sign with it. Okay, if you don't do that, you're going to screw the whole problem up. Okay, you're going to have the wrong signs on coefficients. Okay, so in this case, we take -3 times 2n, which is -6n, and we take -3 times -5. Negative times a negative is positive. 3 times 5 is 15. Equals. Right, now distribute the 1/2. We don't have to worry about a negative sign in front of the 1/2. We just need to distribute the 1/2. So 1/2 times -12 is -6. And 1/2 times 30 is positive 15. Ooh, this one looks like it's going to cancel some things out as well. Okay, so the smallest of the two coefficients on the variables is -6n, because they're the same. So let's add 6n to both sides. So we're adding 6n to both sides of that equal sign. And now -6n plus 6n is 0, leaves a 15. Equals -6n plus 6n on this side is 0. So that leaves us with just this 15. Okay, and we end up with 15 equals 15. So this statement is true. Okay, and you might be able to guess already, but let's write this out. Okay, so when the variables drop out, and the remaining statement almost ran out of room there, is true, there are an infinite number of solutions. So the answer we write here is infinite solutions. Okay, basically what happens in this situation, the words infinite solutions means that it does not matter what number you choose to plug in for n, it's going to make this statement true, okay? Because the two sides of the equation are exactly the same. So it doesn't matter what you put in for n on the left-hand side, as long as you put the same thing in for n on the right-hand side, you're getting a true statement.